Okay, so here's our radioactive decay problem. So the formula that we need to know is we have our amount remaining is equal to the initial times e raised to the negative rate times time. And so we know that the half-life is 1600 years. So we know that when we plug in 1600 for t, we're going to have half of our initial amount, right? So that's what that formula right there means. And then we can go ahead and divide out our initial amount. It doesn't matter what it is because the two numbers are going to be the same, so it's going to divide to equal 1. And so we end up with 1/2 equals e raised to the negative 1600r. And then if you take the natural log of both sides, we end up with the natural log of 1/2 on the other side, and when you take the natural log of e raised to anything, you can go ahead and take that number out, and then the natural log of e just cancels out, so we end up with negative 1600r. And then solve for r, which that's the figure where the calculator comes into play. Now that gives you a decimal, but we're looking for a percentage, so you go ahead and multiply by 100%, and that gives you this. That's the rate per year, and so we're looking for how much is left after 100 years. So you multiply it again by 100, and you end up with 4%. But remember, that's the 4% that's already decayed, as opposed to 4% left. So then you just go ahead and subtract that from 100, and that'll give you your final answer, which is about 96, give or take about 0.3%.